Good afternoon everyone, and welcome to our latest webinar on Upfront Road and Drainage Design for Quick and Easy Approvals. My name's Peter Coombs, and I'm along with my colleagues here today, Daniel Darcy and Max Anderson. So the agenda today, folks, is that we do have a Christmas Eve crisis. In fact, it's pre-Christmas Eve crisis. We've got a Christmas party crisis because it's our Christmas party here tomorrow, and we need some deliverables. We need to get a project delivered on time. We've got a deadline to beat, and we've got mince pies and mulled wine a brewing. So what we're going to do today, folks, is look at a road and drainage design for a brand new development. The client is insisting on a traditional drainage system, and we have a very, very steep site. So we're going to highlight those kind of problems that we're getting with these steep sites. The approving authority, on the other hand, wants SUDs. So there's a conflict of interest in there. And the deadline is not just this week, it's actually today, ready for the Christmas party tomorrow. So what we need a team, and that team is Dan Darcy and Max Anderson. So what's going to happen today is that to deliver this project on time, Dan will be working with XP Site 3D, and simultaneously Max will be working with Microchainage. Dan's deliverables are to connect to an existing highway. So we'd like Dan to show you how to make that connection into an existing highway for your 278s. Dan will also provide the drainage team with the layout of the traditional drainage system such that it's in the highway itself, and also provide the final digital terrain model. Both Dan and Max have the existing grain survey, so they can both work with that straight from the get-go. And we do have a layout from the architect. The design for the finished road layout will be incorporated by Dan, and he will then include the drainage that Max is going to design, as well as introduce some earthworks such as ponds into the model. And at the end of the day, we want to have outputs ready for approval. Max, on the other hand, will identify the drainage outfall locations. So based on the current survey of the site, Max is going to interrogate that, look at the greenfield runoff conditions, and provide that information back to the highways team. And also, ideally, what I'd love for people to do is this, and provide the information to the architects before we even get these layouts, because I totally understand where we're at, in that typically you receive a layout and you have to make the roads and drainage work. If we can do the work that Max is going to show us today and help influence those layouts, it's going to make it a better job, an easier job, and a more effective job for everybody. So Max will go through, look at the greenfield conditions, identify what the greenfield discharge rates are for the site, volume of storage that we need to put under the ground, the big money, the big ticket items. Dan can incorporate that storage volume as, say, a pond within the model. We do have the space for a pond. And then Max will design the drainage network based upon the layout that Dan's providing. And that will be an optimized design. So we're going to have to try and get the net volume within that system. As I say, it's a steep site, so we're going to have a real problem trying to use attenuation back upstream. Basically, I think we'll use Dan to put the drainage outputs in XP Site 3D. So without further ado, for those that have any questions, by the way, do feel free to post your questions in the little window for those that are new to the webinar. We will try to attempt to answer the majority of questions during the event, but we will do a frequently asked question at the end. But without further ado, time's running by. I'm going to hand over to Max to start with the live demonstrations.
Fantastic. Cheers, Peter. So not a minute to lose on this project. So Peter's already mentioned the first thing that I'm going to try and do to try and help Dan and I, when we're making our design decisions, is to get a really good understanding of the site as it is now. So to try and identify those blue-green corridors and have a look at the typical drainage characteristics of my site. And in order to do this, I'm going to use the MD SUDS module of Microchainage. So I've opened it up here, and you can see it's a plan view. And the first thing that I'm going to do is try and load that site survey information. Some of you might be working with LiDAR data as well, now that it's readily available. But here I've got a CAD file from my surveyor, and in it I've got some points information. So I've selected the CAD file, and Microchainage or MD SUDS is now giving me the option to identify that there's a layer in here that I know contains all of this 3D information. It contains information about points and break lines. So if I now say OK, Microchainage is going to read that information from the CAD file and ask me if I want to create a surface from that information, which is exactly what I want to do. So here we go. I'm just going to overwrite this, this surface with the information. And now MD-Suds has launched that directly into the plan view. And if I start to move my mouse across the surface, you'll see down here in the right-hand side, we start to pick up the levels, the Z values there across the site. Just having a look at this, it appears quite brown, but what I'm going to do now is I'm just going to use a better color ramp just to highlight where the low points are, where the high points are. So at the minute, the green isn't showing because I've got a minimum down there of a green of 0. If I actually set a minimum of maybe 30, which I know is a low point on the site, and select a color ramp, there you go. I get a much better representation of the change in height across my site. So up here in the northwest sort of side over here, I've got ground that's going up to maybe 48, 49 meters above our datum, and then down here on the eastern edge of the site, I'm going down to sort of low points around sort of 32, maybe even some 31 levels across here. So I've got a significant fall across the site, just shy of sort of 20 meters. And if I have a quick look with my ruler and have a look at a typical sort of length across there, what you'd be seeing is that's probably something around sort of 400, 350 odd meters. But what I've got here is actually a topo which extends beyond the realms of my site. So what I'm going to do now is I'm just going to load in my architect's drawing for my proposed site bounds. So I've got another CAD file here, my architect's layout. This one doesn't contain any surface data, so I'm not selecting that, and just say OK to bring that in. So now I've got an understanding of where my site actually sits within sort of the larger scheme sort of around it. So if I have a look here, maybe about 46 down to sort of 31, I've got about 15 meters of fall and maybe sort of 330 meters across there. So one in 22 slope Pete's just pointing out got across the site there. And that's brilliant, but it's really useful to have this site survey information slightly beyond the bounds of the site, because what I'm going to do now is I want to identify where the water wants to flow, and then I can use that information to help Dan or maybe highlight if there's any low spots where the architect really wants to put a lot of housing and actually we're getting an awful lot of water accumulating in a sink spot, to maybe adjust the finished floor levels and such. So what I'm going to do is I'm going to use the deluge design tool, and what I'm doing here is I'm applying 50 ml of water in sort of 4 meter by 4 meter grids, and I'm seeing where that water wants to flow after 5 minutes. And you can see it's now produced a nice deluging sort of graph over here of the depth of where that depth's gone from 50 mil all the way up to maybe 0.5. Now we've not got any pink, which is good. We've not got any really sort of strong locations of lots of sort of deep water. But again, I can edit these display settings so that I could look at maybe I'm only interested in areas where I've got more than 100 mil of ponding. So if I adjust that, there you go, that's good. The site doesn't look to have anything at the minute with the site survey. And what I can do is I can see that water's wanting to pool and pond down here on the eastern edge of the site. Well, there's no surprises there. And that's because there's actually a beck here, watercourse that I'm going to use as my outfall point for my drainage design. Can also expand the deluging function on the left-hand side, and I could add hazard rating arrows so that I can see the direction and sort of velocity that water is wanting to flow across the site. So if I zoom in, you'll see the arrows here. They're indicating the movement which is following the topography. No real surprises there. It's trying to move from west to east across the site. So I can see that. So if Dan's coming to lay out the drainage within the highways when he's designing his highways, I know, really, Dan, I want you to be putting the pipes in so they're going sort of west to east, sort of for an outfall location somewhere over here. And that's brilliant. I can see that any water that's discharging off the site in terms of the surface water management is wanting to head down here. And thankfully here I don't have any existing development, so I don't need to try necessarily to mitigate that risk so much. But what I'm going to do finally is get into the nuts and bolts of the site itself, so our site-specific bounds. And what I'm going to do is I'm going to just define just roughly an area around the sort of the bounds of my site now. So just very roughly sort of sketching this out around the site. And once I've done this, I'll be able to interrogate a little bit more information about what's actually been bounded within here. So if I double click this area icon, you can see in here I've bounded 4.37 hectares of site area. So yeah, okay, that's a little bit rough, and maybe I want to refine that at a later date. But one of the things that I can start to use with this inflow area is I could calculate a typical time of concentration for it, perhaps on my longest drainage path length, and see how long is it taking water to flow across this catchment. And to do that, I'm using the calculator. I'm going to base it on Friend's equation, and Friend's equation needs information about the slope. Well, we've got that from Peter as being a 1 in 22. We've just used our ruler tool and a quick comparison of the slope. Maybe a flow path length here of 330 meters, and a catchment roughness, we know it's a grassed area at the minute, of 0.035. And if I calculate that, there you go, travel time is just shy of 20 minutes, in 19.1 minutes there. So it's taking 19 minutes for water really to flow across my site, sort of down towards my outfall point here.
Just got a question, is there any other options apart from the Friends?
Yeah, there is. That's a really good question. We've got lots of different equations in here, depending on where you're working and which ones you might be being held to. So yeah, Friends equation, quite a simple one, some more complex ones in there, depending on obviously the job that you need to do. So if we take away sort of our time of concentration from there was 19 minutes when we were having a look at it with Friends equation. So what we can also do now is I want to have an understanding of my greenfield runoff rates, and I've got some more design tools in here to have a look at those. So I'm bringing up the rural runoff tool. I know I've got a site area less than 50 hectares, so I might want to be using the ICP SUDS. I'm going to probably be interested in my no flooding case, my 1 in 30 years, and 4.73 hectares. We're working today in good old Swindon. Those of you who've watched our webinars before will know that we like Swindon a lot, don't we, Pete? It's Pete's hometown. It was. And Swindon lies in Region 6, so we could again select this from the map if we need to. And we've calculated this, and we can see that we've got a Q bar here of 19.4 litres per second. So perhaps if we've not got good soils, we're going to be held to this Q bar rate, but hopefully we might be allowed to discharge maybe at our Q30 rate, which here is 43.9 litres per second. So I can print that out, I can have that discussion and try and establish what my discharge rates are going to be straight away when I come to do the hydraulic design. Now, because I know something of the discharge rates and I know something of the area, I can also have a quick storage estimate for my site as well now. So using the plan data, it's picked up that area, the 4.37 hectares I've defined on plan, and I can enter my discharge rate. So let's assume a best case that I would be held to, in the 30-year case, to the Q30 rate of 43.9 litres per second. I can now go to calculate that. What you'll see is that it's pulled up a quick validation, and it's telling me that I haven't got any rainfall yet in the model. So I'm just going to go quickly set up some rainfall in my analysis tab. So we'll say not for the minute, we'll come back to that. So in here, I'm going to go and edit some rainfall, create some rainfall for Swindon. So I'm going to call it Swindon, and I'm just going to set up an FSR sort of set of 30-year storms. So my return period is 30 years. The M560 and ratio R values I could select from the map, but I know them already to be 20 millimeters and 0.4. I want to test both the summer and winter profiles, and I want to use a default selection of storm durations. So that's in there now. I can say OK to my design criteria, go back to my design tools, put in that discharge rate again, and calculate. And there you go. I've got a quick storage estimate at my Q30 of between about 900 meters cubed and 1,300 meters cubed. And because of the slope of the site, chances are my time of concentration will be reduced. I'll be looking, I won't be able to benefit so much from attenuation. I'll be looking towards the upper end of that estimate if I'm adopting a traditional design approach. I could also quickly go and change this to my Q bar rate and see what the effect of that would be. And there you go, I'm massively upsizing. I'm potentially having to add another sort of 300 meters cubed on site. So really, I'm going to want to try, if at all possible, to get that Q30 discharge rate. So I've now been able to understand the rural runoff limitations, some of the behavior in terms of the time of concentration, and some quick storage estimate values, which I can now sort of hand over when I come back to doing the drainage design. But first of all, I'm going to hand you over to Dan, and I'm going to say, Dan, everything seems to be draining west to east across this site. We're going to put the drainage within the highways. So could you try and just do me a quick layout based on where you want to put the roads on this site?
I'll see what I can do, Max.
Cracking. Cheers,
So,
Dan.
yeah, good afternoon, everybody. So we've got not much time to do this. We've got a lot of work to do in a short time. So what better tool to use than our incredible XP Site 3D? If you haven't seen it before, I strongly advise that after this you go and take a trial. You'll really enjoy using it. Not only enjoy it, but be able to create really, really good designs very quickly using a very automated tool that is XP Site 3D. Everything I'm going to do, taking Mac's advices on board, is going to be, I'm going to do the road designs as I've been instructed, but I'm only going to show you some of the most frequently asked questions when people first pick up Site 3D. So first of all, I'm going to take off that first 300 mil of topsoil from our site. So that's a frequently asked question. Can we achieve it? Yes, we can. So I'm going to show you how to do it. So I'm going to bring in my original ground survey. This is just a DXF, and I can import that into XP Site 3D. So this is my original site. Now all I'm going to do is go to the surface tools in the tab here, and you'll find the tool called Translate, and this will allow me to adjust the site in a uniform direction. So I'm going to pick the Z direction, and I'm simply going to strip 300 mil the Z direction off our 3D survey. So that's going to drop it down by 300 mil. You can't see much yet, but all I need to do to see what I've done is to save this as a new surface, and then I'm going to compare it against the original. So I'm going to save it as a land XML, and once I've done that, all I have to do is open up again. So I can close this down. All I need to do is open up that original surface, and now I'm going to show you what that looks like in 3D. In Site 3D, everything you do is going to be shown in 3D and live in real time, so there's no worry about missing anything. Now all I need to do is import that surface I just saved. So let's go to our land XML. So now that's going to overlay that on top. So I'm going to go back into the surface tools, and we've got a very useful tool called volumes. This is going to help me visualize the difference between my cut and fill. But what I can also do is define the boundary of the site. I don't want to take off 300 mil of the whole site because that would be a lot of cut. All I want to see is the site in question. So I'm going to import our layout that Max has also been looking at, and you can see that here. Let's just show the original colors just to show you where that is. So right, back into surface, we're going to go to volumes, and I'm going to take the proposed surface and compare it against the 3D surface. Now I'm going to define a manual boundary, and very similar to how Max defined the boundary in MD Suds, and roughly as well for the sake of this demonstration, and we've only got a day to do it. So let's hit finish, got my boundary, hit volumes, and there you go. We've got, now I know I've got kind of low quality, but I've got 15,000 cubic meters of topsoil I can store on the site and use to balance my cut and fill later. But not only that, let's look at this in a different way. I can save this volume as topsoil, not hashtag topsoil, but that's what I'm going to go for. And then hit OK. But what that does, that creates a model that I can then see visually. So if I go to the display settings, I can go to I found the topsoil layer in here, height bands, and I've got a style that's specific for cut and fill. And this is more of an isopack visualization, just to help me understand what we're going to remove from that site. I can then use the earthworks tools to create a spoil heap. That's something you could look at yourselves. So whilst Max was looking at the site data, I was busy working away, putting the first roads down, ready to put that drainage on once I understood a bit more from Max. The reason we're using Site 3D, we haven't got much time to do this project, and XP Site 3D is very, very quick, just giving Max a rough indication of where these pipes are going to sit, much quicker than doing it in Microchainage. So I'm going to just use the drainage tools up here and just draw my runs. I'm just going to follow from west to east, which I've been instructed from Max. We've got a very steep site, so let's take that into consideration. I'm going to show you putting manholes at each junction on the road. We don't want to go under the road. We want to keep the cost as low as possible and have the outfall coming here. I can just quit that off. Very quickly, I just want to show you how you add in an extra run to join a manhole up. It's very quick, very easy. If I zoom in here, and I can just snap, and it's renumbered that, and it just ties everything together beautifully. But all Max needs, I'm going to go fire this away to him, all he needs to open it up is an outfall. So if I right click into the options of this manhole, I can simply hit outfall. Now when I export that as microdrainage, so I'll go File, Save As, and then Microdrainage Project, it picks that up, it's got the network. So I'm going to go away and finish that properly and open up this file where it's already been completed, and I can save that out and forward that to Max. So whilst I send that to Max, I also need to give him the finished, I need to go and finish the road. Imagine what we need to do, or what I want to do to help manage a potential worst case scenario on this road is, what about surface runoff? How about we treat the road as a conduit? So traditionally we would be using 125 curb height, but what I'm going to do is to help manage the surface water, let's raise this a bit higher. And this is a much more cost alternative way of building in storage into the site without having to add suds on such a small scale. So I'm going to hit OK, and we've raised the road, and hopefully Max can show that that might help with potential keeping the water on the site. Right, so commonly asked questions are, how do we tie into an existing road? I'm going to show you how easy that is. So go to the road channel tool. I'm going to draw a center line from this to follow the one that's already there, to snap to the start of this road, right click and finish. And I've got a very useful tool in the road options, centerline extras, and then I can level this centerline to the surface of the road. It's going to warn me that I might destroy a previous alignment, but that's fine. And if I go to the 3D option, if I go to the 3D view, it will just show you, and I'll get rid of the ground for you. You can see there that this blue line, hopefully you can see that, is draped over the surface. Right, now let's add a channel on. So I hit the channel tool, hit the center line. I don't really want a right side of the road, so I can remove that. I don't really want any width off the channel. I just want that curb of footway there. And you can see it's added it in there. Chances are I want to be able to join that up as a road. So if I just show you how you do that, so we can get the junction in there, all I need to ensure is that I snap to this end point. And once it's done that, I'll show you how it will just create that road for us. So again, I'm going to drape that center line to the surface, and that's going to drape that again. And now we're connected to that end point. If I just show you the left-hand side, no width, and hit OK, and that usually would create very quickly a junction. For whatever reason, it hasn't done that right now, but we can show you that later if you want to place that in there. So that's tying into an existing road. We'll show you that later properly. We can show that in a private demonstration. So the next frequently asked question is, what if the actual path or footway comes away from that road? Maybe it's not a continuous profile. We want the path to come away from the actual profile of the road. I'm going to show you how easy that is to do. So I'm going to create another road in here. We're going to go from, just create a simple center line. And we're going to add a channel onto this. And I don't really want to see a right footway, because this is the footway that is going to be amorphous and going to do interesting things. So you can see here, it's given us a junction. That's what it would have done on the tying in. We'll look into further to show you that properly if you want to see that, the demonstration. You can see how quick it is just to add that on. Right, now I'm going to show you a very useful tool, creating a construction line, and also the measuring tools. So I want to know how wide this footpath is. So if I just go and measure that quickly, it's a very useful tool. It's about 1.8 meters. So if I go off there, I want to offset this end of the road by half of 1.8, so 0.9. And now I've got a line I can follow to create the center line of my new path. So now if I go to the path tools here, using the same tools, XP Site 3D is so easy to pick up and learn because all the tools are very familiar very quickly. I can then just go and follow this construction line I've just created to come up this, let's just say it will come up half the way up this road, and it's going to be very crude, but it's followed that radius. Now this path is going to come away, and we can do anything we want with it. So we can come up here. How about we go wild and just throw it over maybe a walkway that goes over the road and comes back down? Or I can enter a coordinate at any point, but I'm just simply being very freestyle here. Before I add the actual channel onto that, I can show you the long section, and XP Site 3D is very, very easy and intuitive to see exactly what you're doing. So if you see, I've got a cursor here, and I can increase the level, the vertical alignment, just by simply adding a point. We're coming along here. I can raise it. You can see on the plan view where my cursor is, and I can raise it, and then it brings it back down. So maybe we want that to go over the road, and very quickly I can just add on that channel at 1.9, 0.9 of course, because it's half. And you'll see we don't want a junction in this case. And just look at that. Look how easy that was to create a path that wasn't a continuous cross section. So that's very easy. So I've shown you a few things. There's ask us anything at all. We'll show in a private demonstration. I can now save this final road, save this surface, and fire that to Max, who can then use it to do the final alignments in his drainage design. So I'm going to pass you to Max, and hopefully you can help us further.
Fantastic. So cheers, Dan. So what Dan's done there, obviously we're looking to implement some highways drainage. So Dan's just sketched out where his roads are going to be and where our drainage network's going to sort of follow the bounds of those roads, saving us having to sort of go into sort of details, getting easements and things like that. So that's fine. So what I'm going to do now is I'm just going to load that up into Microchainage. So Dan's very kindly chucked me over the MDX file, which he's called initial drainage proposal. So I'm just going to open this up into the normal Microchainage network. And one thing to note is that Dan hasn't tried to do any of the design of the drainage network other than purely specifying the layout. So that's now my job as the drainage engineer. I'm going to actually design this and test it and make sure it works from a hydraulic point of view. The first thing Microchainage is asking me when I try to open up this model is what's the design criteria that I'm going to be using. So we know we've got quite a steep sloping site, so we know that our flow for conveyance requirement from service for adoption is going to be the 1-in-1 1-year return period. Again, I can put in my M560 and ratio R values. And what I can also do in here is I could change the pipe size library. So we may not be allowed to use 100mm openings, for example. So if we don't want the 100mm openings, I'm going to change my pipe size library. I can clear all of these, and I'm just going to re-specify that my minimum diameter is 150mm. What I could also do, particularly useful if I'm working on slopes, very sloped sites, is I could specify some fixed slopes or some minimum slopes, which could help me add in some backdrops later on. But I'm just going to leave these sort of for the minute, and I'll come back to that. So I've changed my pipe library, could change my manhole library. Other quick things to point out in the design criteria. Minimum design depth is going to be 1.2 meters because I'm sticking the drainage in the highway, so it's going to be subject to that heavier traffic loading, and as a result it needs to be a little bit deeper. Also, my minimum velocity for auto design, well, I need to be hitting 1 meter per second as per service for adoption. Don't think I'm going to have much trouble with that given the slope on the site. I'll say OK to this. And then straight away you can see that the drainage network that Dan's spec'd out has now been brought in and recognised by Microchainage as a good model. I could also now at this stage, I'm just going to load that CAD back in so I can see exactly which roads I'm sitting under where. So I can bring that directly in. I could also bring in the site survey data as well that I've got initially, or alternatively what's going to be useful later on is taking in Dan's actual road surface. So with all that channeling that he's worked so hard to put in there for the surface water management, and I can see how I can update the model with that later on. But if I have a quick look at the network details, what you can see in here straight away is that we've got some pipe diameters stuck in there as 150s, but crucially we've got areas of 0 being assigned to every single pipe. So what I'm going to do, my first stage now, is to go through and identify the subcatchments draining into each pipe. So the minute any red text Microchainage users will be familiar with that, that indicates something that I've specified. So I want to just remove these, just simply deleting them out, so that Microchainage can start to make decisions on its own. So blue text for those of you that are familiar. And I also want to set the auto design locks off so that we can auto-design every pipe in the network. So say yes to this. Can now start to look at the plan view. If I have an understanding of the site survey straight away, I might know where water is going to try and drain, which subcatchments or how big the subcatchments are going to be for each pipe. And then I can just define these manually using the Define Areas tool from my toolbox, working with the DrawNet module here. Some of you might like to do this in CAD as well. You can use the DrawNet plugin. So for this first manhole, manhole S1, the top of my run, I'm going to say there's going to be an area that's going to drain to this. It's got a percentage impermeability of 100, so it's going to be the complete impervious area. Just for demonstration purposes, I'm going to see what happens if I define a very large area to this pipe. So I've defined a complete area. It's gone into the pipe now. If I have a look back at my network details and we go have a look at this first pipe, there you go. I've assigned 0.8 hectares of impervious area into the pipe. And if I'm able just to move this, I don't know, can I hide? Yeah, fantastic. There you go. The pipe diameter I can now see is 300 mil. And also what it's done, if we go down throughout the rest of the network, any downstream pipes, they've had to be upsized as well to that 300 mil. So all it is now is a case of me going around looking at the topography in the plan view and identifying those subcatchments and assigning them to the manholes. So that's a nice, quick, easy job. I don't have to redefine the pipe network because that's been done by Dan. So in true Blue Peter fashion, here's one I've done earlier. So I've fully defined my site extents now, draining into my drainage network. And we can go have a look at the network details in here. You can see I've got all of my areas assigned in here nicely. I might just want to also have a look at the long sections. And what I tend to like to work with, I'm just going to close down this plan view and then scale the network details and the long sections so that I can see both of them at the same time. So what I finally want to do once I've finished with all of my areas is I just want to optimize the model, try and get my optimum solution from Microchainage. So if I say yes to that, what you'll see here is that Microchainage has had no problem at all in achieving that minimum velocity. But in order to meet the minimum cover depth rule, those pipes are having to be laid sort of following the ground profile very closely. And you can see if we have a look in the pipe network details over here and have a look at some of the slopes on the pipes, we've got some quite significant slopes in some locations, maybe 1 in 15 in one point. I can see that directly, this pipe in the view. And that's going to cause me problems because it's just accelerating that flow down my network, which is going to mean that I'm going to have to provide more attenuation volume because I've got a bigger restriction to put on the flow. I've also, if I have a look at the results table of my network details in here, I can see some green warnings where it's just highlighting to me that the velocities are higher than sort of 3 meters per second, specifically sort of relevant down at the bottom end of the network in here where I've got all of those flows coming together. The convolution of those flows is leading to some quite fast velocities and quite large flows. So this is causing me a number of problems, and I can see that sort of highlighted. If I look at the time of concentration, you remember from the MD SUD study, it was just over 19 minutes. Here it's 7.5 minutes, so 7.5 minutes compared to 19 minutes. It's taking the water in the greenfield condition at least another 12 minutes longer to actually get down to my outfall point, whereas here, obviously, I'm not benefiting from that delay in attenuation upstream in the network. So to me as an engineer, this would really be a great driving force to indicate the need to stop that flow sort of further up the system and implement a sort of SUDS and source control style approach, trying to provide the attenuation and slowing down of the flow upstream in the network. Now, unfortunately, the needs of the client are sort of overriding my desire to sort of do SUDS in this case. So I've been told, no, traditional drainage design it is, in you go, crack on. So this is posing sort of a number of problems for me. So first of all, I've got to introduce a flow control probably at the downstream end of my network, normally in the last but one sort of manhole. So this is going to be my manhole. And what you'll see, because I'm following the slope, is that I've only got this sort of depth in here to provide any attenuation storage before I'd start to sort of encounter water levels higher than this cover level and end up with flooding out of my network. So you can see I've really only got one pipe to benefit from this. So one of the traditional ways that we as drainage engineers might encounter that or compensate for that is to manually introduce some backdrops into the network. So I know that from Microchainage's point of view, this is the optimum, but because I want to control those flows and try and flatten things out a little bit more, obviously there's an economic cost to this, deeper trenches, higher cost of excavation, but perhaps in this circumstance, to try and just alleviate that and reduce the storage volume, I've gotten and manually introduced some backdrops. So I've done that into this scheme here. So if we have a look at the long sections here, I've just manually introduced a couple of backdrops in there, and I've also introduced a hydro brake into the network. So now you'll see there's the cover level of the hydro brake manhole, and I've got a bit more storage volume within the network here in order to provide that. So the final thing I need to do, if I'm trying to design to hit that Q30 discharge rate, perhaps I'd be held to Q bar, given the steepness of the site and the fact that we're not using SUDS, but we'll assume Q30 sort of just for this demonstration case. And I've added in a hydro brake as my online flow control here. Microchainage intuitively picks up some things such as the invert of the manhole and sets the invert of the flow control to be the same. Perhaps I could lower this and add a sump if I was concerned about flow control efficiency, things like that. And I can see the difference between these two here. I've got maybe just over 2.5 meters worth of depth in this manhole because of the backdrops I've been adding in. But maybe I don't want to come right up to that level in the 30-year case. So maybe I'm only going to allow myself sort of 2 meters depth as my design head here. So I've put the design head in here. I could adjust my design flow if I wanted to. But here I've used a typical sort of figure. That would be your Q30. Say OK to this. Now, what I'd find if I still ran this storm now for the 30-year storms is that I'd find that I'd still suffer flooding. And that's because I've introduced the flow control, but I've not done anything to introduce storage or attenuation volumes into the network. If I have a quick look at the results, I've got something called the volume summary static, which displays the total sort of storage that I've got at the minute. So I've not got any storage structures. And my pipe and my manhole volumes is only adding up to provide me about 130 meters cubed of volume. And I know that I'm not even able to utilize that volume at the upstream end of the network because it's too high. So really, I haven't got anywhere near sufficient storage. So my next challenge is to introduce that attenuation storage. Now, some of you might be used to using a quick storage estimate, designing a pond and then having a tinker about with it, but time's really short here. We've only got the day to do this. So instead, I'm going to cut out that iterative process, and instead I'm going to utilize the CastF module, which is going to automatically size the structure that I need to add to my hydro brake manhole. So this is where I'm going to try and put my pond. I know that I've got a pond, the ability to add this pond. So I'm going to use the CastF module to get that size direct, first time, sort of no questions asked. So here I've got it to set up a number of parameters. I can also use CastF not only to add storage as ponds, but also to add flow control. So perhaps if I was doing the source control approach, although given the steepness of this site, maybe not quite as useful, maybe I'd have to use very small orifices. I can also upsize pipes as and when I need to in the model. Go through finally to the CastF controller, and this is where I need to tell it information about where I want it to add the pond. So I want it to add the ponds to the upstream of the final pipe, and I don't want the water level to exceed my design head, but here, rather than 2 meters, obviously it's the above datum depth that I've specified in here. So if we're okay with that, what I'm going to do now is I'm going to kick off microdrainage in what we call the CastF analysis. So here, again, the 30-year return period for the no flooding case, set that up, and now let it go. So CastF is going to whir through this. It's going to run lots of the different storms. Each time it will see if there is flooding. If there's flooding, it will introduce a pond, resize that pond, and just go through this process iteratively. So it's doing very similar sort of to the task that you might perhaps be going through if you don't have CastF already, but where it might take you perhaps half a day to sort of go through this tinkering of the pond design, CastF is going to run through this in merely a couple of minutes. And it's taking some of the error and the guesswork out. And obviously, on a rush job like this, that's really, really useful to me. Hopefully, it's going to mean that Dan and I can make that Christmas party sort of in the end. So we'll just let CastF sort of go through this. Now, if I was using CastF in lots of different locations around the network, it can be quite confusing to see what CastF has changed, where it's made those changes. So what we've got when we look at the results of this is a full audit report of any of the changes that CastF has made. So I'll just have a look. Here you go. Just for the, I don't need to print it. That will come to that sort of later on. I've got the flood indicator on here. I'm not showing any of the surcharging or OK statuses. If I put those on, we could have a look at all of the pipes here, not suffering any flooding. And here's the CastF audit trial that I was talking about. And if we have a look down here, summary of the storage volume that's been added, I can see its plan area take. So I can give this to Dan. I know the volume. And if I just go into the pond network details, we'll see that that tank's been added just as a straight-sided pond to begin with. Now I know that the depth never exceeded sort of 2 meters because that's what I told it to maintain. So if I put those details in here and then highlight this area cell, I now know that the total volume that I provided was 1,356 meters cubed. So now I've got an accurate estimation of the volume and the depth to hand over to Dan for the pond design. So that's brilliant. And I know I've now utilized this. I've solved for the 30-year flooding case, but there are a couple more things that I might want to do to the model. So, for example, the first thing that I want to do is to have a quick look at Dan's updated road conditions as well. So what I've done is I've got another model up here with the updated cover levels given Dan's road design. So if I have a quick look in the plan view, you'll see this sort of if we zoom in sort of to the model here. Don't worry about the blue, we'll come to that in a second. We've got the carriageway sort of details and all that sort of accurate triangulation going on already. And if I have a look at the storm network details, you'll see the cover levels are blue. They've been read from Dan's updated sort of data. So Dan had purposefully looked to use the carriageways as potentially an extreme worst case sort of conduit to help manage my surface water in the extreme cases. So what I've done here is I've run the 100-year plus 40% for climate change tests in the model. Unsurprisingly, I've suffered a little bit of flooding, but now what I can do is I can interrogate these results, and because I've used a flood flow analysis, I've combined the 2D overland flow routing with the 1D network, and now I can have a look at these results sort of in 3D now, and have a look at exactly what's going on. So what I want to do is I want to look at that road that Dan had specifically sort of told me about. He was looking at the channeling on. So we can have a look at this road here. And if I play through the results now, what you'll see is that the 1D network starts to cope with the flows, and then eventually we start to suffer from some flooding. So we've got the surface water flooding now, and that surface water flooding is actually starting to make its way across and down this section over here, all the way down to a point lower down the network. So it's being channeled by Dan's road design here until we get to sort of the flatter area of the roundabout with its area in here. And actually, we specifically put some manholes in here. And if I showed a slightly larger depth of water sort of going in here, what you'd see is that it's actually being collected and reintroduced into the 1D network from these manholes down here. Having a look at the site as a whole, I can see great. Any surface water flooding, these are my maximum depths, have been maintained within the carriageway bounds. So I don't have to worry about finished floor levels and things like that of the properties. I've got great surface water management practice going on here from a combined sort of roads and drainage approach. So that's brilliant. So the final thing that's left for me to do is produce my formal microdrainage reports and also save the MDX model. So I can save this model if I close it down, and that'll be ready for Dan to now introduce into his XP Site 3D model.
Cracking job, Max. Right, yeah, Max has done a very good job in finishing off, making sure the drainage works, the hydraulics. We now know exactly how to finish up the site and put a pond in to help cope with that extreme rainfall. So next 5 minutes, I'm going to show you very quickly how to just throw in that file Max just sent us. He's all finished with the backdrops added. So go import. I can import a microdrainage file. We go to find where Max is. We can add in what Max sent over, and you can see that's added in. Right, so we've got an outfall here. All I'm going to do very quickly is just add in that pond. So let's go to the earthwork tools and just create a new pond. So I need to store about 1356 of volume. So I can just put let's do a nice long thin sort of Lido looking shaped pond here. And we're going to just define the area of that. I can easily use these tools to soften the edges, make it look a bit easier there. So I can just soften these off and then run another profile following that inside. Now I can set the level of this very easily. I can set level to the plane, or I can just simply set the level of this pond. Let's just do 32 meters. So let's change this to 31, just so we make sure we've got enough storage in there. Yeah, so Pete's just said, advised that we can have at least half a meter of freeboard, but I can also add in the water level. So if we do that 32 and a half, it's already saying perfect. It's going to give us that volume in real time. We've got 16, we've got more than enough volume. So what I can even do there to help with the cut and fill, because it's showing us here what the cut is, we can reduce that just to get closer to what Max said. So we can help reduce this volume. We can just play about with it, but that's close enough. And then we can interface this pond just like we can with the roads. I haven't done that yet, but it's very easy. You can just simply interface all of the roads in one go. So I've got the pond done, I've got the road surface done, I can interface the roads very easily. I can also go to the roads and look at volumes to get my cut and fill. So we've got a cut of a fill of 1200, but remember that 15,000 we stripped off the topsoil, so that will melt. That should help use that to balance everything off later on. So that's good information to have. We can also create an ISO pack off the cut and fill, similar to as we did at the start. But most important thing, get information from this and get the project done. So all I want to see is some setting out of the road, some setting out tables. I can click on the road I want to see it for, set the options as accordingly, and just place it where I want. And this is a live document, guys. Anything you do to this will be updated in real time, so there's no mucking about, fiddling and trying to update things later. You won't miss a trick with XP Site 3D. So once I've got that, let's look at the drainage. I can take a manhole schedule. I can show all the relevant information there. That's live again. I update the drainage. That gets updated too. And if you zoom into here, we've got all of this very important information we can add and lay out accordingly. Another thing you're going to want to see is the contouring of the road. So I'm just going to you go with the default, hit OK, and you can see that's added very quickly. You can see it's very easy, shows what's going on with the road. Look at the roundabout, it's done all that and crown lines for you. And if we changed anything, it would change that instantly. So I've got everything there. All it is to do is print that. You can plot it to AutoCAD. You can put your own borders on, but everything there should be good enough to go and get the project done. Gully locations, yes. So somebody's asked about gully locations. So if I go to our drainage tools, we can show it's going to set the gully angle at maximum 45 degrees. And it's just very nice to show exactly where they are, especially with low points. It will add gullies based on standard design practice, where you've got low points, or it's going to add those in for you. So that's fantastic. Hopefully that should be one last thing very quickly. If I just show you the long section of the road, you might want to see, that bit would be very important to you. So you hit the long section tools, hit the road you want to see it on, and the interval. So let's do an interval. So every 10 meters, we're going to take a slice through that road, and that's laid that out very nicely for us. Not much we have to do to edit that, and that's perfect. So I'm going to send this off, and we're going to conclude with Peter Coombs.
Guys, great job. So just to conclude, folks, you can see the problems that we're inheriting now. The incorporation of traditional drainage systems on steep sites. What's the net effect? Well, it's producing this really flashy runoff. In the example that Max gave us, it more than halved the time of concentration from the natural catchment across to the pipe network. And it doesn't afford us any attenuation or minimal attenuation throughout the network. So these are the issues that we're now having to deal with, that we've been building like this for the last sort of 50 years, post-war, in fact. And that's why we need to change the way that we're doing things. How do we do that? We put in sustainable drainage systems. And what we try to do is put those sustainable drainage systems back at source, as far up the catchment as we possibly can. We're trying to slow down this flow to reduce the peak runoff. And ultimately, we're going to reduce the volume of storage required as well. And bear in mind that you have the slowing down of the flow, not just because of the natural characteristics, but because of the actual structures themselves, we're slowing down the flow. So in the screenshot here, for example, coming out of the Syria manual, they're asking us to retain the water for at least 9 minutes within a swale, 9 to 18 minutes within a pond, adding in those retention times. But apart from that, apart from the quantity of the water, we're looking at providing multiple benefits by enhancing biodiversity, improving the ecosystems. We're adding in water quality capability as well. And it's just, isn't this a nicer place to live? So MD SUDS can help us with this, not just for the initial drainage assessments and the flood risk assessments that Max was showing us earlier on, but also to design each of those SUDS elements and create a treatment train in itself. And as I mentioned, this is the software that will enable you to model the flow of the water through the structure itself. Max also showed us the use of CastF. This is how we can provide the optimum storage volume. So we're providing in the correct compliant volume, but at the least cost to the clients. So you're getting both sides of the equation satisfied. And finally, we need to go way beyond the design. We need to manage the surface water beyond the capabilities of the drainage systems. And we need to ensure that that water is contained within the confines of our site and make sure that we don't flood properties. And finally, using XP Site 3D and microdrainage, as Dan and Max did themselves, is showing that these are the perfect partners for your A teams to work simultaneously. This is going to maximize your efficiency, create greater productivity, help you to deliver your deadlines. It's far easier to use, it's more fun to use as well, and motivate your staff so you can provide outputs for approval on time, and hopefully you can get to your office party on time too. So just looking ahead very briefly to the upcoming events, next month we are going to carry out a SUDS design, share a case study with RG Parking from a very steep area of the country, and that is the Lake District. So they're going to share with us a case study on how they incorporated SUDS into a very steep site in the Lake District. So I hope you can join us for that on the 25th of January at midday. We also have microdrainage training coming up at the end of the month, followed by XP Swim training, our flood modeling software, in early February, and more microdrainage training taking place in early March. And just a final heads up, so do please go onto the website and make your bookings now. Certainly March we have availability. I think we have some spaces available for the end of January, early February training as well. So if the places are all taken up, you just won't be able to book online. But if there are dates available, then obviously they're still free. And one final word on the software dispatch side of things. Next Thursday, a week tomorrow, Thursday the 22nd of December is our last day that we'll be able to dispatch any software. So if you're working over Christmas, then that's our last chance to be able to help that delivery for you. Ideally, on future webinars, if you could each register individually, then you can automatically download your certificates and it saves time and it makes you more productive. I'm just going to have to put the webcam on and share this with everybody. So I want to thank the guys for helping us to deliver this project on site. Yeah, I can smell those mince pies. I can smell that mulled wine. And it's just an opportunity to say season's greetings from us all at XP Solutions. Have a great time. Hope you enjoyed the series and look forward to hooking up with you in the new year. And thank you guys. Take care.